No, you're good. See, I told you, don't worry. Okay, I need to throw that in earlier. Find the linear speed in inches per second. If you have angular speed, what's the easiest way to find linear speed? This is the one formula you memorize, the others you could probably figure out.
That's velocity.
Radius times the angular speed gives you the linear speed, right? So, this formula here. So if you know the linear or the angular speed, the linear speed is 5 times 4, 5. I do want to check and make sure that's in the correct units. I want the speed to be in inches per second. Is the 5 in inches? And are my time, is it already in seconds? But always pay attention to that just in case they switch units. Questions about that? Didn't the bell? I figure you'll forgive me someday. Maybe after you pass AP
It's still a baby.
No, what is it? Oh, yeah, I've heard that. I had to in high school.
It's a high school.
It is. Satellite, so this one's kind of a tough one. A satellite traveling in a circular orbit approximately 1,800 kilometers above the surface of the Earth takes 2.5 hours to make an orbit. The radius of the Earth is approximately 6,400 kilometers. Approximate the linear speed of the satellite in kilometers per hour. But what do I need to find linear speed? I need angular speed and a radius, right? Okay. Do I know the angular speed?
Yes.
Sort of. I can figure it out. I know that the angular speed, right now I have 2.5 hours for one orbit, right? Or one revolution. Sorry. What should I do instead?
Just good night.
Oh yeah, but what was wrong with the way I wrote it down?
It was.
Backwards, right? I need revolutions per hour, right?
Hours per.
Yeah, sorry.
Hours per.
Revolution, one revolution in 2.5 hours. Sorry. Right, we agree with that. We need our rotations over time for us to be. I'm going to change the one revolution to 2 pi radians. And am I okay with hours?
Yeah.
Yes, I would like to leave it that way. So it's 2 pi divided by 2.5. And you can even leave it like that if you want. I don't really care. You could change it all into a fraction, or you could do it decimal. Questions so far? Now I need to get the linear speed, which I know is the radius times omega. What is the radius?
6,400. Add the 8
Why do we have to add okay. Satellite is up here somewhere, right?
Yeah.
In orbit. How far up there? 1,800. This is 6,400. So that radius would be both of those combined together. Does that make sense? So what is it? 8,200. So the linear speed is 8,200 times 2 pi
Wait, so your speed to W.
Angular speed. That's how fast it's moving in angles per hour, so radians per hour. But if I want to know distance-wise, how far did I go, then that's what it's called. Go ahead and multiply that out. Give me a number. Yeah. No, go ahead and give me like a decimal. Oh, you need that.
You.
Is that multiplied by 5? 6,000 what? Well,
I got it.
okay. No, you got 5.
I got it. Yeah, that's it.
Okay, so 848. Yeah. Okay, any questions on that? Approximate the distance the satellite travels in hours, 3.5 hours. How do you find distance once you know a rate? And this is actually back to algebra 1. Multiply it. Doesn't distance equal rate times time? And keep that formula in mind. Occasionally it pops back up. If you want time, you divide distance by the rate. If you want rate, you divide distance by the time. We can use that in any. So we have 20,608 kilometers per hour to get the distance. We're going to do that value times 3.5 hours. And what is that? 72,000.
72,130.96.
Any questions about that? Hey, I want you to work on your homework. I imagine we will have to come back together again on some of those challenge problems, but maybe not. One of the challenge problems, part C, no, E, sorry, part E on number 3 will end up being a bonus problem.